Hi everyone, Miss Wisman here with another example of symmetry. So we've talked about rotational symmetry and that it means you can rotate it and it'll stay the same. We talked about how to find the smallest degree of rotation, which means we just count how many times we can rotate it and divide that by 360. But there's another type of question you could get. You could get a question like this: how many degrees counterclockwise would you have to rotate the figure to map point G onto point B? Now, just real quick, it says counterclockwise, which means we're going to go this way. We also always assume counterclockwise. So if it doesn't tell you the direction, always assume you're going to go counterclockwise, okay? We need to figure out how many degrees it takes us to get from point G to point B. So we got to go all the way around like this. What you might notice is I could figure out what each of these turns, how many degrees each of these turns is, right? I could figure out each one of those and then just add them until I get to point B. But to do that, I have to figure out how many turns total it takes me to get all the way around. So 1 turn, 2 turn, 3, 4, 5, 6, 7, 8 turns to get all the way around. In the previous video, we know that if we take 360 and we divide it by each of our 8 turns, we can get what each turn is. So 360 divided by 8 is 45. So each of these turns is 45 degrees. Well, how many of the 45s do we need to get from G to B? Well, 1, 2, 3, 4, 5. So I could add 45 5 times, or I can simply say, hey, it takes 5 turns to get from G to B, and each of those turns is 45 degrees. So what is 5 times 45? Great question. Didn't have my calculator ready. It's 225 degrees. How many degrees does it take to get from G to B going counterclockwise? 225 degrees from G to B. In the next slide, you'll be asked to answer 2 questions, just like this one, where it takes you from one point to the next.